Now example number 2, you've been told to determine the first 4 terms in the binomial expansion of 1 minus 3 over 5x all raised to negative 1 over 2 and state the values in which the expansion is valid. So remember, when the binomial expansion is raised to a fractional number or a negative number, then we use the method of the Maclaurin series expansion of the binomial expansion. Now if you have binomial expansion 1 plus x raised to power n, this one is given by the first term, we have 0 factorial. Remember, if you have n factorial is the same as n into n minus 1 into n minus 2 into n minus 3 all the way until you reach 0 factorial, the last. So to expand the function 1 plus x raised by n, if you have 0 factorial, it means there's no term in the numerator. Then our x is raised to power 0. Then plus, from 0 factorial you go to 1 factorial. If you have 1 factorial, then it means there's one term in the numerator. So one term is that n. Then our x is raised to power that 1. Then plus, after 1 factorial, we go to 2 factorial. If you have 2 factorial, it means there are 2 terms in the numerator. So 2 terms in the numerator will end there. That is n and n minus 1. Then our x is raised to power 2. Then plus 0 factorial, 1 factorial, 2 factorial, meaning we move to 3 factorial. If you have 3 factorial, it means there are 3 terms in the numerator, and 3 terms will end there. So that is n minus 1, and n minus 2. Then our x is raised to power 3. So if you simplify this, 0 factorial is 1, anything raised to power 0 is 1. So 1 divided by 1 times 1 is 1. 1 factorial is 1. So you remain with n of 1 is n times x. So 1 plus nx. So it means in this binomial expansion, the first term is 1, the second term is nx. Then the third term is, now we have n into n minus 1 over 2 factorial, then x squared, then plus n into n minus 1 over 3 factorial minus 2 x cubed. So it implies, when we now have, we've been told to expand 1 minus 3 over 5x raised to power negative half. So to avoid the confusing x with x, we can now say, when you have 1 plus y raised to power n, where there is x you put y, that is 1 plus ny plus n into n minus 1 over 2 factorial y squared, then plus n into n minus 1 into n minus 2 over 3 factorial y cubed. So you are told to find the first 4 terms. So 1, 2, 3, 4. So those are 4 terms. So we want the first 4 terms of the expansion, 1 minus 3 over 5x raised to negative half. So here, where our n is, we have negative half. So it implies, in this case, it implies our n is negative half. And where y is, the position where y is, here we have negative 3 over 5x. So, where there is n in this expansion, we put negative half, and the position y is occupying, we substitute by negative 3 over 5x. So here we have 1 plus n plus ny, but y is negative 3 over 5x. Then plus n is negative half into n minus 1. Negative half minus 1 is negative 3 over 2. Then it is over 2 factorial. Then y squared, but y is negative 3 over 5x. Then plus n is negative half, n minus 1, negative half minus 1, negative 3 over 2, negative half minus 2, negative 5 over 2, then it is over 3 factorial, then our y is raised to power 3 and y is negative 3 over 5x. Then we simplify. So here we have 1, negative into negative is positive, so that is plus a half times 3 over 5 is 3 over 10x. Then negative a half times negative 3 over 2, that is 3 over 4, negative squared is positive, 3 squared, 5 squared, that is 9 over 25, times 3 over 4, 2 factorial is 2. 3 over 4 divided by 2, 3 over 8 times 9 over 25, so that is 27 over 200. So 27 over 200, then our x is squared. Then there we have negative a half times negative 3 over 2 times negative 5 over 2, negative, negative, positive, positive, negative is negative. That is negative 15 over 8. So negative 15 over 8 divided by 3 factorial, meaning times 1 over 6, 3 factorial is 6, that is 3 to 1. Then we have it as times negative 3 cube is negative 27, 5 cube is 125, so 3, 2, 3, 5, 5, 1, 5, 25, 25, 50, 400, negative, negative, positive. So that is plus 27 over 400. So you use your own methodology in algebra to simplify that. Then x is also raised to power 3. So these are the first 4 terms of this binomial expansion, and that is what we were told to determine. So we've determined the first 4 terms of this expansion. Then we were told to state the validity. So to state the validity of a function, the absolute value of that function is supposed to be 0. So the absolute value of y should be less than 0. So what is our case here? Our case here, the function is 1 minus 3 over 5x is equals to negative a half. So it means 1 minus 3 over 5x, if you equate it to 0, remember you don't need to put the power, because if power is there, you can multiply both sides with the reciprocal of the power to get rid of the power, because 0 raised to power anything is 0. So from here, 3x going to the other side, you have 1 is equals to 3 over 5x. So multiply both sides with the reciprocal, 5 over 3. So it means x is equals to 5 over 3. So once you've determined x is equals to 5 over 3, this is now how you state the validity. You simply say the absolute value of x is less than 5 over 3, meaning you first need to determine that value of x. So if the absolute value of x is less than 5 over 3, then it implies x is between the range negative 5 over 3 to 5 over 3. So that is how we state the validity of a function. You just take in the binomial expansion, like in this case, you just take the term minus the power, because it is equated to 0. Then you determine that value of unknown. Once you determine that value unknown, you say if absolute value is less than that given calculation. So that is how we state the validity of any binomial function. Then example number 3,